welcome back to my Python programming tutorials. In today's lesson, we're going to be talking about objects. So in Python, objects are basically custom data types that you can define yourself. As you've seen all throughout this series, we've been using some data types like lists, integers, floats, and so on, and they've been all predefined within Python. However, you're not limited to just those data types. You can create your own data types to model anything you want, basically. So we can model cats, dogs, cars. All we need to know is how do we define what a dog is, what a cat is, and what a car is, for example. Objects and classes are basically just custom data types that you can define yourself. So for this example, we're going to model a car. So let's say we define a car to have some sort of color, some number of wheels, and some position. Let's say we're programming this for a video game and we're going to need the position of the car in case we want to drive it forward or wherever, and then we need to modify that position. One way we can code this up is within our file, we can say like, okay, car1 underscore color, and then it equals blue, for example. And then later on in the code, if we want to create another car, we would say car2 underscore color equals green. But as you can see, this will quickly spiral out of control just because in a program, we can have more than two cars. Let's say we're to have 50 cars, and then we would need to define 50 car color variables and then have them all set and defined. Instead, what would be easier is to create a single car data type, our own custom object, and then create multiple instances of that. And I will go over all of this terminology in a little bit. So as mentioned, this right here, this approach isn't very scalable. So what we would need to do is we would say class car, and then for now we're going to put a pass there, meaning do nothing. And as you can see, if I run this file right here, I can say car1 is equal to car. And now we have a car object. If I log it, you could see it's a car object, and then it gives me some sort of memory address where it's at. For now, this car object stores nothing. We will start adding stuff there. I just first need to go over some terminology so that you better understand what's going on in this lesson. So the first thing we're going to talk about is a class or an object. A class is essentially a blueprint for a specific object. Now, class and object can be used interchangeably, but in Python, to define a class or an object, you would have to use the class keyword and then give it a name. So currently, this car class or car object doesn't have anything in its blueprint. The blueprint would be the code after this colon that would be indented. Currently, it has nothing there. It has just a simple pass, which we know does nothing. But in here is where we would write this blueprint for this class, and you'll see what I mean by a blueprint. An instance is a single unit of a class, so we can create multiple instances. For example, here I've created one instance of this class car. So again, car gave us a blueprint as to what a car should look like. Again, for now it's nothing, but this is a single instance of this car class. Now I can create a second instance of this car by simply saying car2 equals car. And now if I log car2, you will notice that these are two separate objects because, well, they are in different memory location. So these are all instances of this single blueprint, object or class. We can have multiple cars, but they all are defined according to the same blueprint. So that's what an instance is. Now moving on to a class variable. A class variable is a variable that is shared among all instances of a class. So in our code, we might have multiple instances of this car. In this case, we have two instances of a car, but this class variable would be shared amongst all of the instances. So in the example of a car, if these three things are the things we're going to keep track of, well, the number of wheels in each car, well, I'm going to assume that every car has 4 wheels unless there's some 3-wheeled car or 5-wheeled car. For now, we'll just say all cars have 4 wheels. This would be an example of a class variable because it would be shared amongst all cars. There's no point of every car having their own individual number of tires because it's going to be almost redundant. We can just say every car has 4 tires. That would be a class variable. Another thing to remember is that these class variables are public by default. So if you come from like Java or C++, you will have visibility modifiers, which I won't be talking about in Python because I'm pretty sure they don't exist here. If you know about public, private, and protected, just note that in Python, these class variables are public by default. Now moving on to instance variables. Instance variables are variables that are unique to each instance of a specific class. Like we talked about with the class variables, both of these cars will have the same number of wheels. It will be 4. But this car, if we were going to keep track of its color and position, well, car 1's color might be different from car 2's color. And likewise with the position, car 2's position is probably going to be different than car 1's position. And so these are what we call instance variables. They're unique to each instance. And with instance variables, they're not shared amongst all instances. instances. They're unique to just that specific instance, so it has its own variable in its own memory location. These variables by default are public too. So back to the example of the car. Let's start writing out this blueprint for what a car should look. We said that we were going to be keeping track of these three properties right here: color, number of wheels, and position. As we mentioned, the number of wheels right here is going to be a class variable. It's going to belong to the entire class. Well, because every single car that we create will have 4 wheels. We can create a class variable, and the way we would do that is by right under here, we would create the variable name, num wheels, and we would set that equal to 4. And that would be a class variable. Now the other 2 variables, the color and position over here, we said these are going to be instance variables because they're going to be unique to each instance of a car. And the way we create instance variables is going to be slightly different. Firstly, we need to write a method that is called __init__. This is a dunner method or a magic method. We will be talking about these later on in the object-oriented series, but for now you just need to know that this is called the constructor, and this method is run every single time a car is created. Car is created right here, so once this line were to be executed, this constructor would run and it would carry out any code that we would tell it to do. So for now, all we need to pass this constructor is the keyword self, which is a reference to itself. I will go more in depth about this. Then we need to pass the variables or parameters that are going to be unique to every car. So we said that color is going to be unique, and we said that the position is also going to be unique. So I'm going to call it pause. So these are the unique variables that each car is going to need to have before it is created. We create a car, we need to tell it, okay, what color is the car going to be? What position is this car going to be? And obviously those variables are going to be different for every car. So now before I assign these variables, I just want to show you how this constructor behaves. So I'm just going to print car has been created. So this is all we have in our class. This is kind of the blueprint as to what a car looks like. Now if I were to run this code right here and say that car1 is equal to car, I first need to pass it. It's expecting a color and a position. This self argument, don't worry about it, we will talk about it a little more in depth, but we need to pass it a color and a position, right? Because, well, as we said, every car is different, so it will have a different color and it'll have a different position. For the position, I'm just going to pass it a tuple of XYZ coordinates. So we're creating a blue car that starts off at position X, Y, Z are equal to 0, 0, 0. Now once I create this car, you could see that this has been printed, and that is because once this line executes, the constructor or the init method is going to be run immediately. So this is the initialization method. It basically runs every time we create this car, and it starts executing whatever code we tell it to do in here. So for now, we just told it to print car has been created. We don't really want to just print car has been created. We actually want to assign some variables. So as of now, even though we have created a blue car at position 0, 0, this object doesn't really know that because, well, we've never told it to. So the way we would assign these variables of blue and this position is we would say self.color is equal to color, and we would say self.x, self.y, self.z is equal to pause. Again, we're simply going to unpack the tuple that we have passed. So now if I save this and I run this code, I can create car1 again, which is going to equal to a blue car at position 0, 0, 0. So now if I create this, you can see that nothing's being printed, again, because within our constructor, we don't have anything printing anything. Now if we examine what has happened, I can say car1.num_wheels, and it will tell me that this first car has 4 wheels, and that's grabbing it from here. I can also say car1.color, and it will say that it's blue. So now our car remembers that it is a blue car because, well, we've stored it in the variable color right here. We've also stored the x, y, and z coordinate, and we can access them by saying car1.x, car1.z, and car1.y. And as you can see, all those variables have been remembered because we've assigned them in the constructor. So I know this code might look a little confusing. That's why I'm going to go ahead right now and break it down for you. So let's start off with here. This first line tells Python that we are going to create a new class, object, or data type, and we're going to call it car. Put these brackets there for now, although we will go over this in about 2 videos about inheritance. But for now, you don't need to know what goes inside these or why they're there. Just keep them there. You will learn later on. And then we put this colon telling Python that, okay, we are now going to create the blueprint of what a car looks like. So we have defined a car to have a color, a number of wheels, and a position. So this right here is going to be a class variable, like we said, because it will belong to all cars. all cars will have 4 wheels. Class variables are created above the init method, or they're created just in the class definition right here. As I mentioned, this init method or initialization method is a dunner method or magic method. Again, we're going to cover these later on, but this is the method that is going to be run every time we create an instance of a car. And again, this is called the constructor. Now the constructor takes in minimum 1 argument, and that argument has to be self, and then it can have as many other parameters as you would like. The parameters that you would want to pass to the init method are your instance variables. They're basically the variables that you would like to initialize your car with. As we said, each car is going to have a unique color and a unique position, so we would like to assign those once we create the car. We need to pass them to the init method through parameters, which are right here, color and position. Now, the self keyword is a reference to an instance in memory. This self keyword tells Python which instance it is working with. When we do this, Python knows it's working with car1 because of this self parameter. And every time we reference the self parameter, we are referencing a specific instance in memory. So that's why Python knows exactly which instance to assign stuff to. For example, if we were to have multiple instances of this car and we didn't use the word self, well, Python wouldn't know which car to assign these variables to. Because we use the self keyword, Python knows exactly what instance to assign these variables. So it knows once we create car1, then we're going to say car1 has a color which is equal to the color that has been passed through a parameter. In this case, it was blue. Likewise here, this self.x, self.y, self.z means that car1 has an x value, a y value, and a z value, and it's going to equal to position, which is this tuple, and it's unpacked accordingly in this line. So again, that self keyword, it's just a reference to the instance itself. And one thing to know is that all instance method and all instance variables will be accessed using the self keyword. So now we can go ahead and save this and run it, and let's create multiple instances of cars. So let's say car1 is equal to, let's have a blue car, and it's going to be at position 000. So there's our first car. Now let's create a second car. Let's make this car green and at position 111. And let's make a third car, which is also blue and is also at position 000. So there we go. Now we have 3 cars, and if I go ahead and log all of them, you could see that all 3 cars have different memory addresses, meaning they're different instances of this car class. So I can say, okay, car1.color, and you can see that car1 is blue. I can also say car2.color and see that car2 is green. I can access their positions by saying car3.x, car3.y. I can say car2.x, and you'll see that it's 1. And this is how we access all of these variables that we have set. You can access them through this dot notation. So all you say is the name of the instance that you want to reference, and then you say dot and whatever the variable name is that it has. If I go ahead and I change car3.color to, let's say, red, well, car3 is now going to be a red car, and it will not impact any other cars. So car1 will still stay blue, and car2 will still stay green like we have created it up here. So as you can see, neither of the other cars have been affected by this. Now, one thing to know about this class variable right here, numWheels, and these instance variables right here, is that if I create an instance of a car, I have access to each instance variable by referencing the instance's name and then dot whatever the variable name is. So in this case, color. You can see that it's blue. And I also have access to the class variable by saying, again, the instance name dot numWheel. However, if I were to just say car dot color, this won't actually work because the class car isn't an instance and it is trying to access an instance variable. So Python doesn't know whose instance it is to access. That's why it's giving us this attribute error because, well, car is a class definition. It's not an instance of that class. It doesn't have an instance variable. But what we can do is say car.numWheels, and you could see that we can still access it because it is a class variable and car is a class. So hopefully you guys understood something about class variables versus instance variables, as well as instances versus classes. Hopefully you guys have understood why these custom data types are important and how they can be applied in coding. Hopefully you guys enjoyed this video. If the video has helped you out at all, please like and comment as to what it helped you out with. Like usual, if you're new to the channel, please like, comment, and subscribe. It's greatly appreciated. And yeah, I will catch you guys in another video.